In this video, we're going to discuss piecewise functions. Usually when we define a function, we write y equals one expression or f of x equals one expression. But with a piecewise function, if you look at the graph, each piece is going to be defined by a different equation. So I thought it might be helpful to start with an example of when this might be useful. So here we have a scenario where someone is being charged 5 cents per gallon of water for the first 5,000 gallons used that month. But then in an effort to get people to conserve water, the city is going to charge more per gallon once you pass the 5,000 threshold. So after 5,000 gallons are used, then any additional gallons are going to be charged 10 cents per gallon. So let's start by plotting some points. We know that if you use no water, you're going to be charged nothing. So we've got here X representing the gallons of water and Y representing the cost in dollars. And so we know we're going to have the point 0, 0 because if you use no water, you won't get charged anything. If you use 1,000 gallons, that's less than the 5,000, so you're still at the 5 cents per gallon rate there. So if we take 1,000 gallons times 5 cents per gallon, that would tell us the cost for that, which is $50. So on our graph, we're going to have the point 1,000, $50. If we use 3,000 gallons, similarly, if we take that times 5 cents per gallon, then we'd be charged $150. So we'll have the point 3,000, 150. And this pattern will keep going up through 5,000 gallons. So let's see where that puts us. 5,000 times 5 cents per gallon would be $250. So this graph is going to be a straight line segment because it's the same rate per gallon. So we have the constant rate of change that's going to result in a straight line. And so let's plot these points here. So I've scaled my x-axis by 1,000 and I've scaled my y-axis by 50. And so then we can connect those points there. And so there's our straight line segment representing the first 5,000 gallons. Now what happens after 5,000 gallons? Well, you're going to be charged that $250 for the first 5,000 gallons. The first 5,000 gallons are still 5 cents per gallon. Anything beyond 5,000, that's where the rate goes up. So you'll get charged $250 for that first 5,000 gallons plus then 10 cents per gallon beyond that. So let's say we used 6,000 gallons. We'll get charged that $250 for the first 5,000 gallons. Plus now, we've used an additional 1,000 gallons beyond that, right? So for the extra 1,000 gallons that we've used past 5,000, we're going to get charged 10 cents per gallon. So that extra 1,000 gallons is going to get charged at a rate of 10 cents per gallon. So we're going to end up with $100 there plus the $250. And so for 6,000 gallons, we would get charged $350. Similarly, if we used 7,000 gallons, still getting charged $250 for the first 5,000 gallons. Now, if we use a total of 7,000, we've gone an extra 2,000 gallons beyond the 5,000. So we're going to get charged 10 cents per gallon for the extra 2,000 gallons. So it's a total of $450. So we can plot these points now. My graph isn't scaled perfectly, so it might not be obvious here, but this second part that we're drawing is going to be steeper because now the rate has gone up. Now it's 10 cents per additional gallon, whereas before it was 5 cents per gallon. So that rate is the slope of each line. So this line is going to have a steeper slope. I don't have room to show this here, but if you use 10,000 gallons, you'd be charged $750. So we'd have a point up here as well. And so then we can just connect these points that we've drawn in red. And I just put an arrow on the end because theoretically you could keep using more and more water. So we have essentially two different lines here. We've got the red and the blue with different slopes. So if we wanted to describe this scenario, we would need a different linear equation to represent each piece. So here's how we would write this in function notation then. So if we were defining a function f of x to represent the cost for x gallons of water, for a piecewise function we use a brace like this, and then we just list the equations for the different piece, but just the right half of the equation. We already have f of x equals here, so that's like saying y equals, and now we're just going to have different expressions for each part. So the first piece, the blue one, we were just taking the number of gallons times 0.05 because it was 5 cents per gallon. So if x is the number of gallons, it's just 0.05 times x. Now the other thing we do in a piecewise function is we specify which x values this expression is valid for. So in our scenario, we were only charged 5 cents per gallon for the first 5,000 gallons. Once x becomes greater than 5,000, then we're switching to the other equation. So this piece is only going to be valid for x values from 0 through 5,000. Now the second expression that we're going to write is going to describe the red piece. That one started at 5,000 and went forever to the right because you can just keep using more water. So this is for x values that are greater than 5,000. Now writing this expression is a little bit tricky, but if you think about how we did it, we said we're going to get charged $250 for the first 5,000, and then we're just adding on to that the additional charge for the extra gallons that were used beyond that. So it's going to be 250 plus, and then it was a rate of 10 cents per gallon. So it was 0.1 times something, but it wasn't times the x value, right? We weren't charged 10 cents per gallon for all 6,000 gallons, just the additional 1,000 that we went beyond the 5,000. Same thing here, 10 cents per gallon for the additional 2,000. So if you take the number of gallons you're using minus 5,000, that tells you how many gallons are getting charged at that 10 cents per gallon rate. So this will be 0.10 times x minus 5,000. So this is how we would write the function in function notation. We might be asked to evaluate a function value for a piecewise function. So let me copy our function here. All right, so when we are asked to find f of 2000, that means we're finding the function value for an x value of 2000. So in this case, we want to know the cost for 2000 gallons. Cost for 2000 gallons. Now we could find that from just the information in the word problem, right? We'd take 2000 times 0.05 because it's 5 cents per gallon, and that's because 2000 is less than 5000. And that's essentially what we can do with the expression that we have here. We know that 2000 is between 0 and 5000. So we know to ignore this altogether, right? We know to ignore it because it wasn't valid for anything less than 5000, and that's specified here. So since 2000 is less than 5000, we're being charged 5 cents per gallon. So anytime you're asked to find f of something, right, you're substituting that number in for x. With a piecewise function, you have to know which piece you're substituting it into. It's a function, so each x value can only give one function value. So f of 2000 is only equal to one number because a function cannot have more than one output for the same input. We know which piece to use based on the criteria here. And so 2,000 gallons would cost us $100. All right, similarly, f of 5,000, we already found that earlier. That's the cost for 5,000 gallons. 5,000 gallons is included here. It's not included here. This is for anything beyond 5,000. And so for 5,000 gallons, we were still being charged this 5 cents per gallon rate. And that was $250. Now, for 8,000 gallons, we can't use this expression here because now we're looking at more than 5,000 gallons. So 8,000 does not satisfy this inequality. If x is 8,000, this is not a true statement anymore. But this is, right? 8,000 is more than 5,000. And so this is the expression we would use. We would substitute 8,000 for x here, which is essentially what we were doing before when we were finding the cost for more than 5,000 gallons. We were saying, all right, it's $250 for the first 5,000 and then 10 cents for each additional gallon beyond that. So I'm going to stop this video and we're going to continue this discussion in another video, but I didn't want the video to be super long. So hopefully this gave you a good introduction to a scenario of when a piecewise function might be useful, and then be sure to watch the next video for examples on how to graph these.